In this class, I'm teaching to you related to the topic in current electricity. Current electricity. Current electricity. So this is easiest lesson, and we can secure good marks in JEE mains as well as a NEET orientation if you observe carefully the models which I'm giving in this class. Okay, and now, so which topic I'm going to teach to you? That is very important topic. Already you people learned in 10th standard, and that is resistors. What is the topic here? Resistors. And this is one of the important topic and very easy topic also if you learn this topic. And carefully observe what I am teaching to you, right? At first, what is the resistor? What is the resistor? Resistor is nothing but this is the opposition. What is the meaning of opposition? What is the meaning of opposition? It means now we are in the lesson current electricity. We are in the lesson current electricity. Current. What is the meaning of current? The flow of charges per unit area of cross section in the conductor is known as current. Nothing but the rate of flow of charges. The rate of flow of charges. Wherever the rate, the word mentioned, wherever the rate, the word mentioned, in the denominator, time is present. In the denominator, time is present. So now here what I am saying, in the denominator time. Time here I am representing as dt. Time I am representing as dt. The rate of flow of charge, nothing but charge here I am taking it as dq. Charge by time is representing as current. Charge by time is representing as current. So I is equal to, what's the meaning here? dq by dt. I is equal to dq by dt. So this is the current. Why? Because we are in the lesson current electricity, and that's why at first I am giving the definition of current. Okay, and now in this part, why in the part of the resistors I am discussing with you the word current. Why I am discussing with you the word current in the part of resistors? That is very important. Very important. Why? Because resistor, at first I said to you as opposition. At first I said to you as opposition. What is the meaning of opposition? Which can be opposed. Here the current, the flow of charges can be opposed in the conductor. The flow of charges can be opposed in the conductor. So this is the natural phenomena which is going on in the conductor. Natural phenomena. What is the natural phenomena? No one can oppose, nothing but no one can externally apply the force to oppose. No one can do this. Within the conductor, when the charges are moving from one end to the another end of the conductor, and this is the conductor, the charges are moving from one end of the conductor to another end of the conductor. So here this is A and this is B. A to B, the current is passing. So current is passing, nothing but charges are also moving from A to B. And now here I am taking that the charges are moving from A to B. Within the conductor, the charges can be opposed naturally, and that phenomena is called resistor. Nothing but that phenomena can be represented with a term that is resistance. So every conductor has its own resistance. Every conductor has its own resistance. There is a natural phenomena already I said to you. So whatever the physical quantity resistance is present that can be offered by the conductor itself is called as resistor. The conductor itself is called as resistor. So whatever the physical quantity which the resistor offered can be represented as resistance. So at first I said to you as what is the current? What is the current? How the current can be opposed within the conductor, and that phenomenon can be taken with the help of a physical quantity. That physical quantity can be naming as resistance. Resistance is the physical quantity, resistance of the conductor, resistance of the resistor. The conductor itself we are calling it as resistor. Okay, it's very simple, right? So now what is the resistance? Just now we discussed, and now here how come we represent the resistor in the circuit? How come we represent the resistor in the circuit? So here resistor in the circuit can be represented as like this symbol. This is called fixed resistor. This is called fixed resistor. Fixed resistor. And then one more symbolic representation of the resistor, and this is called, I'm representing with the arrow mark, and this is called variable resistor. Variable resistor. This is a symbolic representation of the fixed resistor, and this is the symbolic representation of the variable resistor. Getting? Are you getting the points? Okay. So now here how the resistor can be arranged in the circuit in different ways. How the resistors can be arranged in the circuit in different ways. There are two representations. There are two ways to represent the combination of resistors. Combination of resistors. So at first I'm taking that the first combination is series combination. Series combination of resistors. And this is series combination of resistors. How we should represent the combination of resistors in series order? In series order. At first, I am taking one resistor. This is naming as R1. Resistance of this resistor is R1. This is the first end, and this is the second end. First end and second end. And then another resistor I am taking here like this. This is R2, resistance of the second resistor. So now I combine like this. I arrange the second resistor like this. This is the first end. This is the second end. The second end of the first resistor. The second end of the first resistor is connected to the first end of the second resistor. Listen carefully. Listen carefully. All of you. The second end of the first resistor, the second end of the first resistor is connected to the first end of the second resistor, and second end of the second resistor, second end of the second resistor is connected to the first end of the third resistor, that is R3. This is the first end of the third resistor, and then continuously I arrange it like this. And this is the final resistor I am naming as Rn. Final resistor I am naming as Rn. Resistance of nth resistor. Rn represents the resistance of nth resistor. R1 resistance of the first resistor. R2 resistance of the second resistor. R3 resistance of the third resistor. Like this, I arranged all the resistors one after the other, and final resistance of the resistor is Rn, resistance of the nth resistor. Okay, are you getting? And now This is very simple, very simple. Now I am taking the concept as like this. Very simple. And this is the first end now. First end of the first resistor now. So the first end of the first resistor is connected to the positive terminal of the battery. Positive terminal of the battery. The second end of the last resistor, whatever the resistor can be lost, whatever the resistor you have taken at last, to that resistor, I am selecting the second end. I am selecting the second end. Are you getting? I am selecting the second end. So this second end I am taking like this. The second end of the last resistor I am connecting to the negative terminal of the battery. I am connecting to the negative terminal of the battery. The first end of the first resistor is connected to the positive terminal of the battery. The second end of the last resistor is connected to the negative terminal of the battery. Then this such combination, then this type of combination is known as series combination of resistors. Series combination of resistors. Okay, and now why I'm connecting like this? What is the use of this? What is the use of this? This is I'm replacing with one small circuit. So just now we said that I said to you that series combination of resistors, right? What is the use of taking all these resistors in series combination? Nothing but to compact the size of the device. In olden days, the size of the electronic device is very big. In olden days, we know that the computer size is very big. Nowadays, the computer size is in your hand. It means what? The size of the computer, the size of the electronic device gradually decreases because of all these revolutions, right? So now, instead of arranging all these resistors one after the other, it requires a big size of the device. But that much big size is very difficult to carry. There is no further advancement. So to provide further advancement, here we are taking the concept it as replace all these resistors with one resistor. Whatever the work is doing by these all resistors R1, R2, R3 and so on, Rn, whatever the functioning takes place with all these resistors can be replaced with only one resistor. That resistor we are taking as series combination of resistors. Nothing but equivalent resistance in series combination. We used to represent different ways. Equivalent resistance in series combination or effective resistance in series combination, either equivalent or effective resistance in series combination. Then this is like battery positive terminal and battery negative terminal. Battery positive and battery negative. Series combination we can replace like this RS. So instead of all these resistors, whatever number of resistors are present in this circuit can be replaced with only one resistor, and that resistor is RS, that can be naming as effective resistance in series combination. Effective resistance in series combination. Are you getting? Okay. And now here this is plus and this is minus. I am taking the concept the potential difference is V. The potential difference of the cell is V. Here from the positive terminal the current is passing. See this circuit direction. Always the current flows from positive to negative. Always the current flows from positive to negative. Positive to negative. So from the positive, I current is leaving, and again I current is entering towards negative terminal. This is one closed circuit. From the positive terminal, I current is leaving. To the negative terminal, I current is entering. I current is entering. Okay, and now here this is very important. What I am telling to you here, the current flows only in one direction. Only one direction the current is flowing. Only one direction, and that's why the definition of the series combination of resistors can be given in another way. I am saying to you the one more definition of series combination. One more definition of series combination. What is that? The current is nothing but the resistors are arranged in such a way that the resistors are arranged in such a way that the current flows only in one direction. The current flows only in one direction. Then such combination is known as series combination of resistors. Getting the point? Getting the point? Once again, I'm repeating. The resistors are arranged in such a way that the current flows only in one direction. Only in one direction. Then such combination is known as series combination of resistors. Okay, right. And now this is very important. Here also the potential difference is V. Same from the positive terminal, I current is passing, and again reaching to the negative terminal, the same current I. So here the current passing through the every resistor remains same. This is one of the important point. One of the important point here. I'm saying that the current passing through every resistor remain same. It means I is equal to same. I is equal to same for every resistor. Okay, and then another thing here, which one is varying? Current is same. Which one is variation? Here potential difference can be varied. The voltage across the first resistance is V1. The potential difference across the second resistor is V2. The potential difference across the third resistor is V3. The potential difference across the nth resistor is Vn. Listen, here current passing through the every resistor is same, but the potential difference is not same. How it varies? The potential difference across the first resistor is V1. The potential difference across the second resistor is V2. The potential difference across the third resistor is V3. The potential difference across the nth resistor is Vn. Okay, and now it means what? V is equal to V1 plus V2 plus V3 plus and so on plus Vn. Okay. V1 plus V2 plus V3 plus and so on plus Vn. Okay, and now listen. Here I am taking the concept as according to Ohm's law. Already you know the Ohm's law. What is the Ohm's law? At constant temperature, the voltage or the potential difference across the two terminals of the conductor is directly proportional to the current passing through the conductor. Once again I am repeating, at constant temperature the voltage is directly proportional to the current passing through the conductor, V proportional to I. Then V is equal to, remove proportionality and keep a constant, that is R. V is equal to, what's the value? IR. V is equal to IR. And now I am applying this formula. V is equal to IR. This part V related to the, this is equivalent circuit. This is called equivalent circuit. What is the current in the equivalent circuit? I. What is the resistance of the equivalent circuit? Rs. I into Rs is equal to V1. What is the current? I. What is the resistance of the first resistor? R1 plus current passing through every resistor is same. So whatever the current passing through the first resistor, the same current passes through the second resistor also. So now I is the current. Then what is the resistance of the resistor? R2, IR2 plus IR3 plus and so on plus IRN. Okay, and then IRS is equal to I am removing the nothing but I am taking the constant as I. Why? Because this is a common I everywhere, every term has the current as common. Take out the I as common here. Then here R1 plus R2 plus R3 plus and so on plus Rn. I'm giving the notes this for this one, right? At first, keep the side heading series combination of resistors. Series combination of resistors. And draw the circuit diagram at first. Draw the circuit diagram side by side. Equality must be present in between these two. Equality must be present in between these two. Circuit diagram as it is, you draw this as it is. Okay, so write down first point in this. First point, the resistors or ARE are arranged in such a way that the resistors are arranged in such a way that the current has to flow. The current has to flow only in one direction. Only in one direction. Only in one direction is known as series combination of resistors. Series combination of resistors. Okay. Second point. Next point. Once again, I am repeating the same statement. The current passing through every resistor, the current passing through every resistor is same. The current passing through every resistor is same. Okay. Third point. Write on this one. V is equal to V1 plus V2 plus V3 plus and so on plus Vn. Next point. According to Ohm's law, according to Ohm's law, according to Ohm's law, V is equal to IR. Write on this. V is equal to IR. According to Ohm's law, V is equal to IR. V is equal to IR. Next line, write down. The potential difference across the first resistor, the potential difference across the first resistor, the potential difference across the first resistor is V1 is equal to IR1. V1 is equal to IR1. V1 is equal to IR1. Next line. The potential difference across the second resistor, the potential difference across the second resistor is V2 equal to IR2. V2 equal to IR2. Next line, write down. The potential difference across nth resistor, the potential difference across nth resistor is Vn is equal to IRN. Vn is equal to IRN. IRN. Next line, write down. The potential difference across, the potential difference across, the potential difference across equivalent resistor, equivalent resistor is V is equal to IRS. The potential difference across equivalent resistor is V is equal to IRS. IRS. Now, write down. Now, write down this step. IRS is equal to IR1 plus IR2 plus IR3 plus and so on plus IRN and so on plus IRN. Take out the I as common and then cancel both sides, and this is final equation. RS is equal to R1 plus R2 plus and so on plus Rn. R1 plus R2 plus R3 plus and so on plus Rn. And so on plus Rn. Okay. Right on the next point. If identical resistors are present, if identical resistors are present, if identical resistors are present, so what is the meaning of identical resistors? The resistance of all the resistors is same. It means R1, write down, R1 equal to R2 equal to R3 equal to and so on equal to Rn, that is equal to R. R1 equal to R2 equal to R3 equal to and so on equal to Rn, that is equal to R. So it means RS is equal to R1 replaced with R plus R plus R plus and so on plus R. Like that, how many times it repeated? N times. N times. Then RS is equal to N times repeated. That's why here NR. This is another important point. RS is equal to, what's the formula? NR. NR. Okay, so this is the important topic in the case of resistors series combination, right? So after that I'm discussing with you the parallel combination of resistors. All this part is series combination of resistors. The next part in the combination of resistors as parallel combination of resistors I'll discuss with you. Okay,